All right, welcome to our next video in the series on programming in Java. This is the second video in the object-oriented programming playlist. We're going to be talking today in detail about state and behavior. State and behavior. So the idea is we're going to be able to add a better sense of organization to the increasing complexity of our program by dividing our code up between a client class that's going to take advantage of other classes, which we're going to call helper classes. The analogy I've used is that you are going to be the owner of a dog daycare, a kennel. You want to have dogs on site and you need to track their information. You need to know name, age, and whether or not they're vaccinated. So something that's useful is we look at the helper class and we see that we can organize the code that lives there into the state and the behavior. The state are going to be the variables that each dog object can have. And another name for this is going to be a field. We would say that the fields of the dog object are these variables that make up its internal values. The thing to know about this is they're not like any other variable in that we can provide them a layer of protection to make sure that they are not ever inappropriately used. And the way that we protect these variables are through something called setters and getters. The official name for these is mutators and accessors, but I think most people call this setters and getters. And the idea behind a setter and a getter is if I have a method whose job it is to control how the variables of name and age and vax are changed, then I can prevent something from happening that shouldn't happen. So what does a setter look like? We would say public, void, so the setters never need to return anything, they're just setting. And let's say the first thing I want to do is say set name. Well, I need to have a name that I want to set for it. And what I do is I'm going to say this dot name equals name. So this is a complete setter right here. It's a little hard to understand what's going on. I'm going to go back to our client class to show you how this gets used. If I create a new dog object and I say d1 dot and I want to set the name and I'm going to say Boomer is the name of my dog, then this string Boomer gets passed as a parameter to this d1 object. And the d1 object's like, what am I? I'm a dog. Let me look in my class and see what this method is supposed to do. Oh, I'm supposed to take a parameter name and assign it to one of my pieces of state. So the reason I wasn't allowed to just say name equal name, because we've got two values here that are being identified with the same identifier, right? We've got name and name. I need to differentiate between what is the variable that lives with the object and what is the parameter that's being passed to this method. So the way that I specify, hey, I'm talking about the object that called this method, I'm going to say this dot name. And you'll notice how in Eclipse, the nice thing that it does is it uses a different color so that you can see that this name and name are different. So Boomer, the string, got passed as a parameter, and then we say, all right, take that string Boomer and save it into this object. So after this line of code gets run, if I go ask, hey, D1, what value are you holding in your name object? It should print out Boomer. Yay, and there it is. Good job, Boomer. We want to, in an ideal world, when you set up a helper class, you want setters and getters for all of your fields, for all of your members of the state. And there's a reason for that. Let me go ahead and build in another value. Let's say we were going to say set age, int age. So right here, you might think that the answer is I'm just going to say this dot age equals age. But what if, I've got a new employee and they're not very responsible? And what if my new employee tries to do something like this? What if they try to say d1.setAge and they accidentally say -2? -2. Well, I mean, I don't know, absent a time machine, there's no way to have a dog who's -2 years old. I mean, unless you're working with some kind of a Benjamin Button supernatural experience. The benefit of having a setter is that I can add a little bit of code. I can add a little bit of logic here to say, look, if age is greater than or equal to, I'm just going to say greater than 0, then go ahead and say this.age equals age. If they tried to give us an age that's negative, we can make a little print statement that says invalid age provided. Oops, and I suppose I should make that a string literal. And so now what's cool is, I make the boomer dog, or I make the dog object D1. I set its name to boomer. I go to give it the mistaken command, and rather than let my field hold an invalid value, I was able to protect my code and make sure that age doesn't hold a negative. This is so beyond useful for when you're making big projects, you're writing a lot of code, and you get more and more distant from lines of code that you wrote 50, 100, 200 lines ago. You want to leave yourself certain protections so that if you make a mistake, your code doesn't just quietly accept that mistake and then crash and choke later because you don't want it to be hard to find your error. So why do we use setters? We use setters to make sure that only valid values are given to our pieces of state. So is it a pain to type out all of these things and to provide the if? Sure, it is. But that's a lot better than, just remember, if instead of a setter, I said d1.age equals -2, dot access is kind of reckless because there's no way to protect myself here from that invalid value. I could make age negative, and that could cause all kinds of problems in my program later. So we like to make sure that if we're going to change one of these values, we don't use dot access, we use setters and getters instead. What does a getter look like? A getter, so I guess this was setters, which we also call mutators because they mutate the value. And then a getter, what does a getter look like? Accessor. So I just, for the record, so there's no confusion, I should also have a setVax method right here, and I just won't type that out so that this video is shorter. Public, if I'm going to get a value, it means I need to return it. So I'll do this for the vaccine one. Get vax. Doesn't need a parameter because I'm not sending information to my field. I'm getting information from my field. So I'm going to say return vax. I could say return this.vax to make sure I am ultra communicating that the vax I'm referring to is the one that belongs to the object. It's this field variable right here. I don't know if that's 100% required. I think for our purposes, for a high school class, we can just say return vax. Why do we have getters? All right, it makes sense why we have setters because we want to be able to protect, if we were given maybe a name that includes a bad word or an age that's negative, or I guess if you're only providing true or false, it's hard to have a bad value for vax. But why do we have accessors? Well, we're going to talk about something in a future video called encapsulation, which is where I'm going to take all of these fields right here and I'm going to make them private, which means I'm going to shut off dot access so that I can't recklessly invalidate one of my fields. Now, how we use the private keyword, what exactly is encapsulation, that's the subject of another video. So I'm going to say don't worry about that one for right now. So the next step in our process in object-oriented programming, we know that objects contain state and behavior for us. And now we've learned that in order to properly maintain and retrieve that state, we want to use setters and getters to ensure that none of the state that we have here is ever invalid. Okay, thanks for watching.